Modeling, Topic 2, Section 6, Computing Implied Volatility using the Black-Scholes Option Pricing Model, also called the Black-Scholes-Merton Option Pricing Models. So this Black-Scholes model is a mathematical model to calculate the value of a call or put option. The inputs to that model include the risk-free rate, the maturity of the option, the strike price, the dividend yield. However, the biggest input, or the most uncertain input, an important one, is the expected risk or annualized standard deviation of the asset's returns. Now, you can use the Black-Scholes model to find and use goal-seek function in Excel to find out what is the standard deviation that ensures that Black-Scholes returns the market price of the option. That standard deviation, which is called the Black-Scholes or the implied vol, has been shown to be a good predictor of future volatility. So here is the formula we'll explain in future topics. Right now it's just a function we're going to use. So this function called BS call and this one called BS put are the simple formulas that Black-Scholes and Merton developed to price options. What we're going to do is we're going to copy these formulas. We're going to put them into a module. So I'm going to back out of here. I'm going to go back to my PowerPoint. I'm going to copy those functions. Control C. I'm going to go to my Excel start file I've been working on. I'm going to hit Alt F11 to get to the VBA editor. I'm going to insert a module and I'm going to paste. So now BS call and BS put are in my functions, in my modules. I can then value this option on SPY. Let's say that this option, so today's date is March 1st. This option matures April 1st. The strike price of this option is $280. Spot price is $279.19. 2.5% dividend. The annualized 1-month interest rate is 2.40. I'll use my prediction of my long-term forecast of volatility of 13.25 for SPY. The maturity of this option is 1 month, so I put 1/12. And let's say that I observed, let's say on Bloomberg, that the price of this option is now trading at $4.20. I want to see what the Black-Scholes thinks it's worth. How I'm going to do that is I'm going to get rid of that question mark, and I'm going to insert a user-defined function called BS call, where I'm going to put in the spot price, 279, the strike price, 280, the volatility, 13.25, the interest rate of 2.40, the maturity of 1 month, and the dividend yield of 2.50. And what that tells me is that option, according to Black-Scholes, should be selling at $3.85. The actual price is $4.20. So I could say that if this is a good estimate of volatility, I think this option is overvalued. I think it's only worth $3.85. However, we're not using this model to value the option. We're actually using this model to predict volatility. So what we're going to do is try to figure out what volatility that goes into this model will make the model option price equal to 420. So I'm just going to do a data, what if, goal seek. I'm going to set the Black-Scholes price to 420 by changing vol, the standard deviation. When I do that, I'll hit OK. It looks like 1433. We'll call that the implied volatility, the Black-Scholes implied. And what that's been shown is, since this is a 1-month option, that number's been shown to be a decent predictor of volatility, annualized volatility, over the remaining month of this option. While we're talking about implied volatilities, I want to talk about one other concept, concept in finance, and that is the VIX, or fear index. So, going back to our PowerPoint, when I go to Yahoo Finance, and I ask for symbol VIX, little hat there, VIX, and I asked for a last 5 years. What you can see is this graph is a graph of implied volatilities of short-dated S&P 500 options, roughly 30, 1 to 30 days. And what this shows me is at the most recent date, 1495 is the implied volatility for the next month of the S&P 500. So that's the market's, one way of thinking about it, it's the market's estimation of volatility over the next month, and that's 1495. So if I look over this average period of time, looks like the average standard deviation implied volatility of the S&P 500, let's call it, I don't know, 15 to 20% range. The current estimate of volatility says it's going to be about average. That number has been as high in the last 5 years of 30% and as low as looks like 9 or 10%. We call this VIX is often called the fear index, meaning when that number is high, the market, the options market at least, is predicting that a high period of volatility, a period of high, big changes in stock market returns. Here's our full worksheet we've worked on through sections 1 through 6 and topic 2. If you want more information against any of the topics in section 2, you can look at this Math is Fun website that has a standard normal distribution discussion. There's a book I highly recommend, Against the Gods, The Story of Risk, The Remarkable Story of Risk. That's on Amazon. That talks about kind of the development of the mathematics behind finance and statistics. This one here is a time scaling of volatility. This one here, Investopedia, has a discussion of EWMA, especially since that's not covered in the textbook. This section here has a discussion of implied volatility. This link here has a discussion of it's the graph of the VIX, that fear index. And this one here has a discussion of population versus sample standard deviations and variances. So this finishes topic 2, sections 1, 2, 3, 4, 5, and 6.